So SP1C is acceleration, so we've just moved on from distance time. We introduced the equation speed equals distance over time. We're now going to look at acceleration and what that means, and we have a few more equations as well that are linked to acceleration. So first question is, what is acceleration? What does it mean if something is accelerating? And the easiest answer is to say that the car speeds up. All right, so if something speeds up, then it is accelerating. That's the basic way of saying what acceleration is. But if we want a full definition, we can say acceleration is how the velocity changes. And remember, all the way back to SP1A, velocity is a vector which has size and direction, but it's a speed vector. So speed is the scalar with just size, and velocity is the vector, which is speed in a certain direction. So acceleration is how the velocity changes, or how the speed changes in a certain time. Okay, so how an object's velocity changes. Now that could be speeding up, but technically also it could be slowing down. Because as long as the speed changes in a given direction, which actually means acceleration is also a vector, because acceleration is direction specific. If you have positive acceleration, then you are moving in the forwards direction. You could be speeding up or slowing down, which is known as deceleration, or you could be accelerating in the negative direction. So you could be speeding up backwards essentially, or this way, or even slowing down in the negative direction. So positive and negative actually means that it is a vector and it could be acting forwards or backwards. So velocity, how the velocity changes, speeding up or slowing down in a certain time. Now the equation that we can introduce now, this is the second equation that we have to remember. This won't be given to us in the exam paper, we have to remember this one ourselves, is acceleration equals the final velocity, or the final speed, minus the initial velocity, which we could also say is technically the change in velocity. So final velocity minus initial actually means a change. So for example, if I start at 0, so I'm stationary, I'm not moving, and my speed increases to a speed of 10 meters per second, then my final is 10, my initial is 0, so the subtraction 10 minus 0 is 10. The change in my velocity is 10 meters per second. Another example of finus minus initial, I could be walking at 3 meters per second, and then I could start running at 8 meters per second. My final is 8. My initial was 3, so 8 minus 3, my change in velocity is 5 meters per second. All right? Now that's the first thing we need to consider. The second thing is, how much time did that take me? Okay, because in order to know what the true acceleration is, I know that acceleration happens when the velocity and the speed changes. So I went from 3 meters per second to 8, so I've changed my velocity, but how long did that take me? Because I could do that in a really long time, which means my acceleration is really low, or I could go from 3 meters per second to 8 meters per second in a really fast time, which means I'm accelerating quite high. All right, so final velocity minus initial velocity divided by the time that it takes. If we write our equations in symbols, then it would be A equals V, so final velocity is V, minus U, so initial velocity is U, divided by time. So it's all divided by time. So A equals V minus U over T, which represents final velocity minus initial, which is a change in velocity divided by time. Now, again, how do we rearrange this? You have to remember this equation for the exam, but the exam may not ask for calculate the acceleration. They could say calculate the final velocity, or they could say calculate the change in velocity, which is actually the whole top part of this fraction. So if they say, for example, find the final velocity, you know that you're looking for V. Okay, so let's rearrange this equation. For V, the first thing we're going to do, because the t, time, is on the bottom, remember it's divided by time, it's on the bottom. In order to move that to the other side of the equation, I have to take it to the top by multiplying to the other side. So that's going to leave me with V minus U equals A times T. So we had V minus U divided by T equals A, but I'm looking for V, so the first thing I'm going to move, I can't move the minus U yet because it's on the numerator, it's on the top of a fraction. I need to get rid of the denominator, the bottom of the fraction first. So to get rid of this T to the other side of the equation, because it's divide by T, I multiply by T, so A times T. So V minus U equals A times T. Now all I need to do circle the one I'm looking for still, so I don't lose which one I'm looking for. V is what I want, minus u needs to be moved to the other side, and I do that by adding. So if it's minus u, I plus u. So the final equation for v is going to be a times t plus u. Now remember, v is the final velocity, a is the acceleration, t is the time, and u is the initial velocity. Now, a lot of questions in the exam, they actually say that the initial velocity of an object is 0 because the object is stationary, or they may say it starts at rest. So if an object is at rest, it means it's not moving, then u is 0. So actually it makes it easier because I can get rid of the plus u because it's just 0. So the final velocity would be equal to acceleration times time if the object starts from rest at 0 velocity. All right, but if it does start at initial, for example, I was walking at 3 meters per second and then I increased my velocity to 8 meters per second, then I do have a u value. So the final v would be 8, but the u would still be 3. Okay, or they might say acceleration is 1, time is 3 seconds, u is 3 meters per second, find v. So you have to put that plus u in there if there is an initial velocity. All right, let's try another one then. So again, in the exam, they could ask for, it's very common that they do, they could ask for the time t. So in my equation, in the question, I have an acceleration. They gave me an acceleration. They told me the final and the initial. It could be, they said, the change in velocity. Remember, this whole top of the fraction, final minus initial, is the change in velocity. So they might not say you start at 0 and you go to 10. They might say the change in velocity of an object is 5. That could be from 0 to 5, but it could also be from 15 to 20. All you need to know is the change in velocity is 5, is the top of the fraction. V minus u, you already have the change. All right? So if they ask for the time, what time does it take for this change in velocity or this acceleration? Let's rearrange the equation. I'm looking for t, it's on the bottom. Take the t to the other side on the top, so it becomes a times t equals v minus u. So a times t equals v minus u because I times or multiply by the time on the bottom to take it to the top. But remember, I'm looking for t, so I now need to move the a. Just like speed equals distance over time, I still need to move this a, so t is on its own. The a is multiplied at the top, so I take the a to the bottom. So t would be equal to v minus u divided by a. So the a is at the top, it's a multiply, I divide by a, take the a to the other side on the bottom, t equals v minus u over a. That's two ways of rearranging. It's very, very unlikely that they would ask you, they can, but it is unlikely that they ask you for an initial velocity. But because it is something they can do, there's no reason they can't ask you for an initial velocity, which means you must rearrange to find u. So we'll just do that last one. I'll get rid of all the others so we can do the last one to find u. So we've done v, we've done t. We're now going to rearrange this equation. If they ask us for an initial velocity, how do I rearrange a equals v minus u over t to find u? The first thing I need to do is take the t to the top on the other side. So that's going to be v minus u equals a times t, same as before. Before I was looking for v, so I added the u. Now I'm looking for the u, but the u has a minus, which is going to cause trouble if I leave it as a minus. So what I'm going to do, I'm going to add the u to the other side again. So I have v equals a times t plus u. Exactly the same rearrangement when I was trying to find v. But now, because I'm looking for u, remember, keep circling the one you want to follow. I'm looking for u, I'm going to subtract. Now this a times t I could put in a bracket, because that's together by a multiplication, and it's plus u. So there's a plus separating at and u. If I just want u, I'm going to subtract the whole bracket. I'm going to take away a times t, and I'm going to be left with u equals v minus a times t, and that stays together in the bracket. So the rearrangement to find u from this equation is u equals v minus a times t. So you do the a times t in the bracket first, and then do the v, the final velocity, minus a times t. All right? That's the equation for acceleration that we need to remember. Now, in this equation for acceleration, it only considers the change in velocity and the time. there is an equation that is given at the back of the exam. So in the GCSE Edexcel paper, they give you this equation at the back of the paper. They also give it you in words as well. So final velocity v squared minus the initial velocity u squared equals 2a acceleration times x. X is the only new thing in this equation. In the previous equation, it was a equals v minus u over t. Time has vanished, but we now have a new quantity, which is x, and that in this case is displacement. All right, so v is final velocity, u is initial, the same, a is acceleration, but x is the displacement. Now remember, displacement is just distance, but in a certain direction, so it's a vector. But in the equation, x is just the distance traveled. So if in the exam question it says the velocity of an object, or the final velocity of an object is 2, the initial velocity is 0 as the object starts from rest, and the acceleration of the object is 3 meters per second squared, find the distance traveled by the object. You'd use the equation at the back of the exam. Sometimes they say use an equation or select an equation from the exam paper. Sometimes they don't. You have to think, this is the equation that I need. But how can you know whether I have to use v minus u over t, or do I use this equation? Because they both have acceleration, they both have final and initial velocity. The easiest way to remember which equation to use is to make a list of what you were given and what you were asked for. This equation has acceleration with distance. If you have an acceleration in the exam question and you were asked for a distance, or you have a distance and you're asked for an acceleration, then it must be this equation. But if they have an acceleration with a time, then it's the previous equation, a equals v minus u over t. This one has acceleration with time, this one has acceleration with distance. So if you need this equation, then it's something to do with acceleration of an object with the distance or displacement in that question. All right? Very quickly again, we have to rearrange every equation. This one is given to us, so it's nice and easy. We'll take it from the back of the exam. We still need to be able to rearrange. The most common questions or the common rearrangements of this that they ask for in the exam are find a, the acceleration. So let's find a first. So if they ask for a, all I need to do is divide, because it's times by 2 and it's times by x, so I just divide them. So a would be equal to v squared minus u squared, all divided by 2x. So here is the rearrangement of this equation if they ask me for a, the acceleration. Okay? Don't forget, in this equation you have a squared on both the final velocity and the initial. A lot of students in the exam, they just do v minus u and divide by 2x. You have to square the final velocity. Let's say that the final velocity of an object is 10 meters per second. The initial velocity of the object is 2 meters per second. The final v was 10, so 10 squared is 100. The initial was 2, so 2 squared is 4. 100 take away 4, 96. Okay, do not forget to square your answers. Alternatively, they could ask for x. Another common question in the exam is, here's the acceleration of the object. You have a final and an initial velocity. What is the distance traveled, or the displacement of this object? So I'm looking for x, and I'm using this equation from the back of the exam. I know it's this equation because it said acceleration and distance, not acceleration and time. So same again, x is what I'm looking for, 2a multiplied by x, so I just divide it to the other side. So x, exactly the same as before, v squared minus u squared, all divided by 2a. So it's just the opposite, just divide by 2a instead of dividing by 2x. Same again, substitute your values into the equation and find the value or the answer to what is the distance. I'm not going to rearrange for v squared and u squared. They've never asked for a rearrangement of this. But again, it is something they could do, but ask your teacher or practice it yourself. See if you can rearrange. I'll give you a clue. Do the same thing. If it's minus u squared, you have to plus it. But if you're looking for v, so for example, the exam asks for the v, the final velocity. There is a squared on here. Think about what the opposite of a squared is, and it should be the square root. All right, so try and rearrange the equation for v, knowing that there'll be a square root in there when you get to v squared equals. You have to square root it to find v, or even for u squared, which would be the harder one, similar to before, that's a minus, so it goes to this side, and then we take everything else to the other side. But to get rid of the squared, you have to square root, all right, at the end. So try that one. But like I said, the most common equations and questions they ask in the exam for this one are find a or find x. So the rearrangement is quite straightforward. You just divide by the 2a or divide by the 2x. All right, and that's the section on acceleration.